Welcome to Science course. This is lesson number 1, School of Elements. My name is Sunita Mutha and I will be your lesson instructor. I am supported by StudActive team. In this video, we will learn about classification of elements, the need of classification of elements, and the various attempts made by scientists to classify elements. At the end of this video, you will learn what were the attempts made by the various scientists to classify elements and whether these theories were discarded or accepted. In the last video, we have studied about Daubernia's law of triads, Newland's law of octaves, and Mendeleev's periodic table. Today we will go a step further. Today we are going to learn about the periodic table, which is accepted universally today, given by Henry Moseley. Now, Henry Moseley had arranged these atoms in the increasing order of their atomic number and not atomic mass. Earlier, all the scientists had arranged elements according to the increasing order of atomic mass, and hence there were so many anomalies that were faced. But Henry Moseley observed that atomic number is a fundamental characteristic of an element and not its atomic mass, because there could be two elements having same atomic mass, but there cannot be two elements having same atomic number. For example, argon and potassium. The atomic number of potassium is 19, while the atomic number of argon is 18. But the atomic mass of argon and potassium is both 40. Hence, it is the atomic number which is a fundamental or unique property of an element and not its atomic mass. And hence, when the elements were arranged according to their increasing order of atomic number, the anomalies which were observed in Mendeleev's periodic table were all corrected. For example, let us consider these two elements, argon and calcium. We know that the atomic mass of argon and calcium are both approximately equal to 40. Hence, they have the same atomic mass. But the atomic number of argon is 18 and that of calcium is 20. So, now we understand that it is the atomic number which is a fundamental property of an element and not its atomic mass. So, when Henry arranged the elements in the increasing order of their atomic number, all the anomalies that we have seen in the various theories given by Mendeleev or Newland or Daubernia were all corrected. Before going to modern periodic table, let us learn modern periodic law. Modern periodic law states that the chemical and physical properties of elements are a periodic function of their atomic numbers. That means that the elements will repeat their properties after a certain regular interval of atomic number and not atomic mass. The modern periodic table is also called as long form of modern periodic table. Let us look at the modern periodic table and let us see what we observe. The first thing that you will observe is that modern periodic table resembles very much with Mendeleev's periodic table. Let us learn the features of modern periodic table. First, there are horizontal rows in modern periodic table similar to Mendeleev's periodic table, which are called as periods, and the vertical columns are called as groups. There are 7 periods and 18 groups. Next point, these periods are numbered from 1 to 7. Elements in the same period will have same number of shells, which is equal to the period number. Let us take an example. Hydrogen, which belongs to period 1, also has 1 shell. Lithium, which belongs to period 2, has 2 shells because we know that the atomic number of lithium is 3. Hence, its electronic configuration is 2, 1. Next point, In each period, a new shell starts filling up. The period number is also the number of shell which starts filling up in it. Next point, let us learn about the size of the period. We can see that the first period contains only two elements, namely hydrogen and helium. So it is the shortest period. The second and the third period are called as short periods. Each of them have 8 elements. The fourth period, which starts with potassium, and the fifth period, which starts with rubidium. The periods 4 and 5 have 18 elements, so they are called as long periods. The sixth period is the longest period, which has 32 elements. Now, let us go to groups. We can see that there are 18 groups numbered from 1 to 18. Elements which have same number of valence electrons, that is, they have same outer electronic configuration, are present in the same group. Let us take an example of group 1A. Lithium, sodium and potassium. Let's see the electronic configuration. Lithium 2, 1. Sodium 2, 8, 1. Potassium 2, 8, 8, 1. What do you notice? The common thing between all these three elements, you will notice that all of them have one valence electron in their outermost shell. Also, they belong to the same group, that is 1A. Hence, we say that the elements having same number of valence electron are present in the same group. Next point, elements in the same group show same chemical properties. Since they have same number of valence electron, hence they will have same valency, and hence the reaction with other elements will also be similar. So they will have same chemical properties. Lithium, sodium and potassium and the other that follows them are all alkali metals. When they dissolve in water, they form strong alkalis. Let us see group 2 elements. They are called as alkaline earth metals. Group 17 elements, they are all called halogens. That is, fluorine, chlorine, bromine, iodine are all halogens. Group 18 elements are called as inert gases or noble gases because they don't react with any other element. They don't react because they are complete, because all their shells are completely filled. It will be observed in the periodic table that on the left hand side we have all metals, whereas on the right hand side we have all non-metals. Metals like lithium, sodium, potassium, beryllium, magnesium, calcium are all placed on the left hand side because they are strong metals, while elements like fluorine, chlorine, bromine, oxygen, sulfur and so on are all placed on the right hand side because they are strong non-metals. Now, when we learn about this table, let us understand that elements are also classified into 4 types, and this classification is normal, transition, inner transition and inert elements. Now, what are normal elements? Elements whose one outermost shell is incomplete only are called as normal elements. For example, elements present in group 1 and 2 and from group 13 to 17 are all normal elements because the only one outermost shell is incomplete. Let us see this in the example of fluorine. In fluorine, only the outermost shell, that is, which has 7 electrons, is incomplete. Hence, it is a normal element. Next, transition element. Elements which are present in groups 3 to 12, which are in the middle of periodic table, are called as transition elements. Let us take an example of manganese. We can see that in manganese, the last 2 shells are incompletely filled. Hence, it is a transition element. What are inner transition elements? Inner transition elements are those elements in which last three orbits are incompletely filled. Next, inert group or zero group elements, also called as noble gases. These are those elements whose all shells are completely filled and hence they don't participate in any reactions. As we know, these elements are divided into S block, P block, D block and F block. Let us understand this block. We start with S block element. S block elements consist of two groups. Group 1. Group 1 will have valence electron 1 and group 2. Group 2 will have valence electron 2. Let us go to P block, which is on the right side of periodic table. Group 13 to group 18 is collectively called as P block element, and hence the number of valence electron in P block elements would be 3, 4 and so on up till 8. P block elements consist of metals, metalloids and non-metals. In fact, this is the only block which contains all the three kinds of elements, while S block contains only metals. Let us go to D block elements. D block elements are the elements which are contained in group 3 to group 12. All the D block elements are metals and also they are transition elements. So they are metals which are also transition elements. Let us go to F block elements. You can see that the F block elements are at the bottom of periodic table, which are also called as lanthanides and actinide series. They are all inner transition elements and also they are all metals. So we can say that S block element and P block elements are all also normal elements except the zero group. The D block elements are transition elements and F block elements are inner transition elements.